Good evening, everyone, and thank you very much for having us tonight. It's a huge opportunity for us to be here, and I've got to thank the university and everyone for putting us in these shoes. Let me start by how this all came to be. Last year, us as a small group of electrical and electronic engineering students decided to build a car that we aptly named the part1. It's half a motorbike and half a car, so it gained the nickname part1, and it's got 3 wheels. What we did as a couple of students is, from scratch, we designed and built this car to race in the South African Solar Challenge 2010. The South African Solar Challenge is a race around the country. We basically went from here down to Cape Town, PE, Durban, and then back up to Pretoria again. The whole purpose of the race is to promote green energy, and I mean, it's actually a solar race in general. But the car we built was hybrid in nature. It ran off a little R6 motor that was in parallel with an electric motor. The electric motor was powered by batteries, and the batteries could be charged by a hydrogen fuel cell that was on board. From this, we gained a lot of momentum, and we decided to build a real solar car and enter into the race for 2012. Where we're sitting now is we're building a car that is completely solar powered. It's got solar panels as the power plant, batteries, and a little motor as a drivetrain. If I can show you the pictures of where we are now, and I'll take you through a tour of the labs and the workshops, and you can see that what you see in here is where we headed towards. It's concept from mechanical engineering, design students to give us the art faculty of it, and then the electrical guys are facilitating the vehicle with its powertrain. It's everything from the sun to batteries, and then the drivetrain. Solar car is, I'm sorry to say to the other guys, the flagship because of the solar race, and that's where we get most of our coverage from. So there's a lot to be seen on the solar car. The next car, which will be presented by Sven and Charles, they are going to show you what the hydrogen car is about. So what we've basically done is we've taken a hydrogen fuel cell stack that was donated by one of our sponsors, MTN. These hydrogen fuel cells are used as a supplement station on their base stations to supplement their power if the grid goes down or anything like that. And we've taken this fuel cell apart, wrecked it for lack of a better word, taken it to pieces and used what we can out of it to put a power plant onto a car that resembles what you see in this picture over here. Okay. We've developed this car, we've had a mechanical master student to design the car from scratch. And this car will then facilitate the hydrogen fuel cell as a power plant on the car. The car is basically an electric car, all of them are. It's a sort of electric motor, batteries, and then each of the cars has a power plant, so we call it. So the power plant in this particular car would be the hydrogen fuel cell, which generates about 5 kilowatts of hydrogen fuel, of about electric power. And from this electric power we have, it's the greenest energy we can get because its only byproduct is water. So if we can produce hydrogen cleanly from solar power or, well, Eskom, if you will, for now, the only byproduct of having a hydrogen car is water. So that's a great car as far as the green energy goes. The last of our cars, which Tony will be presenting on, is our turbine car. What we've taken, we've done a little turbine gas generator. We've coupled that, well, it's actually a turbine gas generator that then creates a huge amount of thrust. There's a freewheeling turbine, and then the freewheeling turbine goes through a little gearbox, and then that goes into a generator to create our little power plant that is basically our turbine power plant, if you will. And the reason for using a turbine is that it can be a lot more green. If we look at the efficiencies of what a normal car engine would be, we're looking at about 30% because of its heat cycle, where we can push it up to about 60–70% just because it's a turbine. So that and the advantages of running it off alternative energies, alternative gases, makes us want to look at turbine energies. All of these cars in their own right has got a green aspect to them, but more importantly, the platforms are to facilitate an academic medium. We're looking at using these cars, and that's the reason we've gone the hybrid route, is that there is a huge academic depth in having a hybrid car. You've got to manage energy, it's not just about having the alternative energy, but we've got to be able to manage whatever energy we have. So what we've got the 3 different teams, and we've broken them up between different students of different levels. We've got the 4th year students, which are our specialist engineers. We have 3rd year students, which become our general engineers. They do everything from wiring, the telemetry systems, the energy management systems. The specialist guys would do a specific converter on the car and design something specifically for the car. And then we've got our 4th year master students, which you'll probably be meeting some of the guys tonight. And they do all the systems from, they do all the management, and they do the system engineering as how everything's going to come together. So we've structured each team to compete against each other as though it were a company. So that's the experience we're trying to get. The best part about having these projects is that it's a real world problem. So we're trying to give our engineers and our students as much of a real world problem to deal with as possible. And what more of an exciting platform could we ask for than having your vehicles? From here, I'd like to hand over to Warren Herter, who's our solar guy, and have him explain a little bit about the solar car. Thanks, Warren.
My name's Warren Herter, as you mentioned. In terms of the solar car, basically we were a group of about 9 undergraduate students that took on this project. The team was comprised of 3 industrial designers that worked with Peter, our sort of aerodynamic guy, to sort of give us the pretty design that you've seen quite recently. We looked at focusing on mostly the aerodynamics of the vehicle. It needs to be as aerodynamic as possible. This being a solar vehicle, that is where your biggest losses are in this type of vehicle. So we focused on that, but we didn't want a standard sort of solar car. We wanted something that looked good. So, because the standard design is around a cockroach. I mean, nobody really likes a cockroach. So we went with some styling. We spoke to the industrial guys. They gave us some sleek lines on the body. We looked at what sort of shape we would be working around. Also, we had to do a lot of research into what we're actually going to be manufacturing the vehicle out of. How we're going to be working with these solar panels. So as you can see, I'm busy cutting some fiberglass there. Basically, what we needed to do was encapsulate our solar panels in some fiberglass, which is something that hasn't really been done too often at the university. A group from the UAV research group tried to do it for their solar flyer to sort of strengthen the solar panels, because as you can see, they're actually manufactured from 0.15 millimeters of glass. So they fall apart like there's no tomorrow, and you put them on a car, they're going to just break, and you sort of put the driver at risk as well. So we needed to figure out a way of actually strengthening the solar panels, but not losing all of our efficiency at the same time. So on the vehicle itself, we have 514 solar panels covering 6 square meters. Now that sounds like a lot, but that gives us about 1 kilowatt of power, which if you think about it, as the standard kettle puts out about 1.2 kilowatts. So we're basically running the car on less than what you use to make a cup of coffee. And we're going to be running at between 80 and 100 k's an hour. So everything needs to be as efficient as possible. From the motor, we had to try and find as efficient a motor as we could find within our sort of price range. We had to add things like a CVT, which is a continuously variable transmission, just so we don't drain the batteries too much when we're pulling off. Also, the body, we needed to design the body as light as possible. So we've used composites throughout. We've used fiberglass sandwich panels. The entire frame is made from aluminium. The electronics, the converters on the actual system are all custom made by undergraduate students. We're getting efficiency of about 91%, which is very good considering the guys are designing it for their first sort of time. So in terms of designing it, it was quite a tricky setup. You can see the ribs and stringers there. They're the sort of internal structures of the vehicle, all made from marine ply, which is actually used quite commonly in aircraft and vehicle designs as well. It's a very lightweight wood that we actually got water jet cut in specific shapes that just slotted together to support the actual body, so that at speed nothing sort of bends in terms of the actual fiberglass frame. Everything has been manufactured here. We had a few components outsourced, such as the manufacturing of the molds for the body. These were all CNC cut from polystyrene. So I mean, these are all things that undergraduates are basically doing. I mean, when we started this, we knew nothing about it. So we've had to learn very quickly, basically, to sort of figure out what we're doing to actually produce this vehicle. So as you can see, here is the actual aluminium frame with all the sort of attachment points. We've had to sort of customize our own sort of steering system. Like I said, everything was designed on computer beforehand by the students. We had to basically analyze everything as well. The chassis had to meet FIA specs, so it had to basically, the roll cage, for instance, has to withstand a 2-ton load to protect the driver. You can see there's one of the body sections that we pulled from the mold. Also, what we did, interestingly enough, is just to make sure everything works properly, we built a 5th scale model of the entire frame. So the chassis, the ribs and stringers, all of that, just to sort of make sure that everything fits together nicely. I mean, you'd rather screw up a small frame than the actual full scale system. So there you can see we've got the electric motor fitting very snugly in there. That's, as I said, attached to a CVT as well. So that's the final sort of render that we're looking at. We're about 3/4 of the way done. you'll see we've got the 3 top sections completed for the vehicle. It's just the molds that basically we're trying to finish off at this stage. So ultimately within the next month we should be rolling. The vehicle can drive already. It's just a case of finishing off the body that we want to focus on at this stage. So yeah, we'll take you across to the workshop. I'll explain everything there again if you guys are interested. But that's as far as we are at this stage.